Saxon Algebra 1, Lesson 56. Today we're going to talk about a really simple concept called sets. Sets are groups of numbers that mathematicians may choose to talk about in the context of some sort of problem that they're doing. And we can name them and note them. So, for example, we can say, here's a set of numbers. We're going to call it A. And it consists of the odd numbers. Now, the odd number is greater than 0. Now, I could sit here for a long time listing odd numbers, couldn't I? In fact, I could spend the rest of my life listing odd numbers and I would never complete my task. You guys, I got other things to do. I don't want to do that. I don't want to sit here for the rest of my life listing odd numbers. So what I'm going to do is something much simpler. I'm going to put a dot, dot, dot. And that tells you, and so on, right? This is called an infinite set. Obviously, because these dots imply that you follow the pattern for infinity. All right? I can choose another set of numbers and say, these are the first, sorry, I'm having a hard time talking. These are the first 4 odd numbers greater than 0. In this case, I don't want no dot, 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 because I only want the first 4. So this is the complete set, and this is called a finite set. It ends. Okay? So I want you to be familiar with those words. All right, now let's go on and explore what it means to be a set a little bit. In a set, we list each member. The numbers are called members. Only once. And I'll show you an example of what I mean by that. All right. And we don't have to list in order. Now, I will confess to you right off the bat, that bugs the heck out of me. I prefer to put my sets into chronological order, but the important thing is you don't have to. It's not necessary. Okay, so what John's going to do in example 56.1 is he's going to give us a little chance here to walk our talk, and he's going to give us a chunk of numbers. Let me just show you in the book so you can see. Lesson 56. Represent the following numbers as being members of set K. Okay, so K is the name of it. Here are all the numbers, and as we can see, there's a lot of repetition going on there. Somebody is just making this harder than it needs to be. So what we're going to do is we're going to clean this up. We're going to say, okay, if it's set K, then we'll make the nice K, right? Just like we did here. We'll say equals. We'll make the opening parentheses. Now, I'm going to go through this list, and I'm going to write each number only once. I'm not going to duplicate, okay? So 1, 0, 2, I'll read them to you. Then there's another 1. Then there's another 0. There's a 5. There's a 7. There's a 4. Then there's another 5 and another 7. Okay, so I've listed them only once, and I controlled my need for order, breathing carefully, and I left them in a wonky order. All right, so that is the answer. John went ahead and put them in order from least to greatest. I mean, I'm for it, but it's not necessary. He makes a point of saying you don't have to, and then he goes ahead and does it. So whatever, John. All right, now we have another problem just like that. Represent the following represent the following numbers as being members of set L. The letters are random for our purposes too. If we were the mathematicians working on this big project, there might be some logic to that. We might just be going in order, but we don't know what it is. All right, so here's the list. I'll read it to you. 7, we need it. 15, 0, 1, 15, already got it. 0, already got it. 8, -13, 42. Okay, this is way more random than this one, but it's okay. Random is fine. Then there's one more symbol that we want to introduce. It's this symbol, and that means is a member of, or the way I learned it back in second grade was that it's the same as saying is an element of. Element and member mean pretty much the same thing, and this looks like a little e. So we can say things like 0 is an element of set L, and we can say 23 is not an element of L. Simple, right? Okay. We have a couple more in this topic. This is not hard. Would you agree with me? It's just kind of fun. When I was in about second grade, there was a big fuss in schools, and they started teaching what they called new math. And what it really was just mathematics using some organizing ideas that mathematicians were developing as they moved into the digital age and started to develop computers. So it created some new language, and they started introducing that into the schools in the mid-60s, which was when I was in second grade. And I thought it was really cool because my dad worked in computers way back. He started working in computers in like the late 50s, early 60s. He was a mathematician at University of Michigan. I know, mathematician. And so I thought it was really cool that we were learning this language that mathematicians used in working with computers. And that's when everybody was focused on going to the moon, and we knew that going to the moon was going to require a lot of development in our computers. So this was all tied up in this exciting phase of, at least my life. In my family, it was a really big deal that, you know, computers were coming and math was part of it, and we're going to the moon, and new math helps kids learn how to speak the language of computers. So to me, this was really exciting and fun. Okay, enough of my autobiography for today. That's chapter 4, you guys. Stay tuned for the rest. Okay, in this problem, we're being given 4 sets of numbers. A equals, I'm copying this out of the book, 0, 1, 3, 5. Oh, well, hallelujah. They're in order. Thank goodness. Somebody believes in straightening up a little bit around here. 0, 4, 6, 7. Beautiful, tidy. I love it. And C is 1, 2, 3, 5, 7. Notice that nobody has to tell us these are sets. We can tell by the notation. The letter, the equals, and then the parentheses on the end. We know those are sets. Now we're given 3 statements, and we're asked if they're false or true. True or false. Why did I switch the order on that? Okay, so this question says 5 is an element or member of A. So we go look at set A. Is 5 in there? Yes. So we say true. And John says, I agree. B, 4 is an element of C. Member or element, same difference. My brain just was trained to say element. Okay, is 4 a member of C? No, sorry, that's false. Oh, John, he agrees. He tried to trick us. It didn't work. C, 5, and then we have this symbol, the slashy. 5 is not an element of B. And we go, look. Yeah, there's no 5 in there, so this is true. 5 is not an element of B, so we give it a T, and we're happy. Yay! Okay. All right. If you were doing this in the homework, you wouldn't have to write all this down. It's in the book. I'm writing it down so you can see it without me shoving the book under the camera and making you squint at the tiny little numbers. So I'll copy this one too, but you don't have to do this. L is the set of 0, 1, 2, 3. M is the set of 5, 6, 7. And N, again, these letters are random, is the set of 0 and 1. And now we're supposed to figure out A. It's true and false again. 6 is an element of L. False. It's heresy you speak, John. He agrees. And B, that's an A. It looks kind of weird. B, where am I? 0 is an element of N. That's true. I agree. Yay, we got those right. Okay, that is what we call set notation. We're going to build on that as the years go on, but this is not going to get particularly complicated. It's just, again, mostly language, vocabulary for you to learn. Okay, let's change gears. That was A and B, by the way. John broke that into 2 categories. Oh, decreased my pages. What? What is this? Heresy. No. Okay, it's fine. Part C is we're going to talk about graphing a little bit more. And last time, or a couple times ago, we learned how to make a little table, right? We would draw a chart, and then we would be told some clever little equation that we were supposed to graph, right? It might be something like y equals 3x plus 2, right? And then we would make the little chart. My charts are different than John's, and don't tell him, but my charts are better than John's. So make yours like mine. We put the x here, we put the y here, then we write this part up here. Then we choose numbers for x that are easy and simple, that'll keep us close to the middle, and then we calculate what the y will be. So for example, let's choose 1, and that would be 3, and then we plug the 1 in, right, to this expression. We chose 1, so let's plug that in. That would be 5, right? Let's choose 0, because 0 is always fun. And that would be 3 times 0 plus 2. Ooh, 3 times 0 is 0. So 0 plus 2 is just 2. And then let's choose -1. I mean, honestly, you guys, you can't go wrong with these 3 choices. A lot of students find this really hard, and they get all weirded out and skeezy about this process because they don't know how to pick the values for x. You guys, you can't go wrong. Just pick whatever you want and keep it really simple. Like, you cannot go wrong by choosing these every time. Sometimes there might be some fractions that will create drama with these numbers, and we'll talk about that when we get to them. But you can't go wrong with 1, 0, and -1. Let's multiply. 3 times -1 is -3, plus 2 would be -1. And then these are the points that we plot, right? 1, 5, 0, 2, -1, -1. And you don't have to write them over again. You can just read them off the chart, which is why I like my chart. But I wrote them there just so you could be really clear. Let's practice graphing them. This is all review, by the way, just so you remember that I haven't told you anything different yet. All right, 1 and 5. 1, 1, 2, 3, 4, 5. It's right there. 0 and 2 would be there. And -1 and -1 would be there. So look, there's our line. It's a little wonky, but then I just free-handed the heck out of it. You guys, if you like to do things neat and precise, ask your mom to get you some graph paper. Ask your older siblings to give you some graph paper. Sneak in their rooms when they're having a snack and steal some graph paper. No, just kidding. Don't do that. They'll get mad. But if you get caught, tell them I told you to do it, all right? I read Princess Diana's autobiography over Christmas break. I know, that's kind of random. She was very much into the hijinks, and she told one of her sons, Harry, if you're a royal follower, she told Harry when he was a little kid that he could be as naughty as she said, you can be as naughty as you want, just don't get caught. Oh my gosh. I love that so much. And I agree. So don't get caught stealing the graph paper. But if you do, you can blame me. Okay, so anyway, this is the process that we've learned. But we've always been given the equations in this nice form where it's y equals something times x plus something else. That's a really important formula that we're going to spend a lot of time talking about. I'm just introducing it to you now. We're going to spend lots more time talking about it. But we need to get our equations into this form before we can start this whole chart thing. So what John's going to do now is he's going to be very mean, and he's going to ask us to graph, but, oh wait, 56.5. He's going to give us this kind of garbage and tell us to graph that. Well, we can't graph it like this because it's not in the right form. So what we have to do is we have to swim this around. As I like to say, you guys, we have to hit it with an algebra stick to turn it into that, okay? So the first thing we want to do is get y by itself on the left. So let's subtract the 3x. And now we get 2y equals minus 3x plus 4, okay? So one is isolate the y term. And what I mean by y term is it's okay that it's got a letter in front of it. We just want the clump with the y in it on the left. And then we divide by the y coefficient. That's fancy math talk. What that means is 2 is the number chilling in front of the y, so now we have to divide that to make it go away. And so we get y equals minus 3/2 x plus 2. I simplified that, and notice what I did here. I kind of rewrote this. I put the 3 over 2, and then I shoved the x separate. That's because I'm trying to protect this form. That's fine. You can do that. And it makes the math a little bit easier because look what happens. Now we'll set up our table. X, y. This goes on this side. Minus 3/2 times x plus 2. It's going to make it easier to plug that in. Now, here's where this isn't necessarily the best choice. We have a denominator of 2. So when we do the multiplication, I want to choose numbers that are going to cancel against that 2 and make it go away. So the best thing is just choose the denominator itself. So now we're going to multiply minus 3 over 2 times 2, and I can make it 2 over 1 if that helps my life at all. Now look what happens. The 2's cancel, which is what I wanted. This is minus 3 over 1. I can ignore that. Minus 3 plus 2 is minus 1. So by choosing wisely, I can get rid of the fraction drama. And the way to choose wisely is to choose a number that will allow you to cancel against your denominator. All right, let's choose negative 2 as another one. Minus 3 over 2 times minus 2 over 1. Okay, these cancel. This turns this into a plus. So this becomes plus 3 plus 2, so I get positive 5. Oh, interesting, right? And then let's do 0 because he's always tried and true. And that is minus 3/2 times 0 plus 2. Okay, that just goes to 0. No fraction can stand in the face of a 0. He just wipes them right out. And so this will be 2. There are our x and y pairs that we want to graph. I'm going to squeeze my graph in here. And since I need to have that y go all the way up to 5, right? So I'm going to plan ahead. 5, 4, 3, 2, 1, 0. See how I'm being strategic about how I write my graph so that I'll have the numbers I want available to me? Feel free to do that. Okay, 2 and minus 1. 2 and minus 1. Minus 2 and 5. And 0 and 2. 0 and 2. Okay, that looks pretty good. And I can draw a line to connect. Like so. The name of this line is y equals minus 3/2 x plus 2. Is it right? Yay, it's right. The fractions did not scare us. We just chose points so that everything would cancel in our multiplication and life would be happy. Let's do one more that's easier. This is the harder of the two. Ready? Example 56.6, ready? Y minus x equals 0. Okay, that looks alarmingly simple, but we can see, oh, it still does not fit our dream date here, right? We want the y by itself on the left, and we want everything else over there. So fixing this is going to be pretty easy. We just have to add x to both sides. Y equals x. Oh, well, that one's pretty easy, right? I mean, I don't really even need to write anything in the middle. Because, oops, that should be a y. If x is 1, then y is 1. If x is 0, then y is 0. If x is -1, then y is -1. There's no calculation, right? It just is. So that's really easy. But we can go ahead and plot point it. And then -1 and -1. There it is. So this is a good one to memorize, you guys. Because when y equals x, which is what we have right here, this is how it will always look. It goes right through the middle, divides that one right, it divides it cleanly in half, and it divides this quadrant cleanly in half. Easy to calculate, easy to do. Don't you love ending on a super easy problem? Doesn't it make you feel strong and smart and ready to tackle your homework? Oh, I know, I'm so excited for you. Okay, I'm done. Lesson 56. Goodbye.